Hi, I'm Krishna. This is day one of 30 days of understanding modern AI stack. Today we're learning backpropagation, the thing that literally made modern AI possible, made GPT possible, made driverless car possible. Before 1986, neural networks were basically useless for anything deep. We could make them guess, but we had no efficient way to correct them. We did not know how to push errors backward through multiple layers. So deep learning wasn't deep, it was shallow. Then backpropagation algorithm came. This single idea unlocked everything we have today. CNNs, transformers, ChatGPT, Gemini, video generation tools, and all of it. Backpropagation is simple at its core. It tells the underlying network of these models during training how wrong it is and which weights cause the mistake and how to nudge them to fix it. Let's break it down simply. A neural network works in two phases. Forward pass, it makes a guess. Backward pass, it fixes itself. In the forward pass, we compute a prediction and a loss. The backward pass answers one question: how should each weight change so the loss goes down? Now here's where the chain rule comes in. We want to know how does the loss change when we move this one weight a tiny bit. But a weight influences an activation which influences the output and which influences the loss. So we create a chain of derivatives backward. So here's a simplified version of how we calculate derivative of loss with respect to weight using chain rule. You don't need to memorize this, just understand the idea. We break the error down into smaller pieces and trace it backward step by step through the network. Modern frameworks, actually tools for machine learning like PyTorch, build a computational graph during the forward pass. This graph stores all the intermediate values needed for derivatives. Then when you call dot backward function, the framework walks that graph in reverse and calculates the gradients automatically. Backpropagation tells each weight, here's how much you messed up and here's how much you need to move. This tiny movement is the gradient. Then gradient descent updates the weight, where new weight is equal to old weight minus learning rate multiplied by gradient. As you can see, if gradient is positive, weight decreases. If negative, weight increases. Step by step, the network adjusts itself. Do this millions of times across millions of parameters, and the network starts understanding patterns, images, speech, language, everything. This is literally how you build your own ChatGPT. Forward pass, compute loss, backward pass, adjust weights, repeat until the model becomes smart. So here's a simple analogy. Think of the movie Free Guy, where Ryan Reynolds plays an NPC who keeps dying and messing up, but every day he adjusts what he did wrong the previous day. That's backpropagation. Fail, get feedback, make a tiny correction, and repeat until you become unstoppable. So that's backpropagation, the algorithm that lets AI improve itself. In the next video, we'll look at how these gradients move using different optimizers like SGD, Momentum, and Adam. If you want to see the math behind the backpropagation properly, I have linked a really good video in the description. Go check it out. See you in the next video. Let's do it.